Hi there. Thank you for watching this sort of inaugural, very first uh, video series for going over what we're going to continue to call 5-minute practices, except maybe we're just not going to do that for grade or in class per se. But hopefully this is going to be very helpful for you to get more practice on some of the problems we do in lecture as well as in the homework. So this first one, we want to think about the cycloaddition reaction that's shown right here. Notice that this is indeed a cycloaddition mechanism we're showing because, well, A, we're making a new cycle ring, but also because the flow of electrons is in a cyclic manner. That's kind of the more important part of this mechanism. And it's all concerted, meaning it's a one-step process. And the premise of this problem is that we want to assume that this reaction indeed does happen. And when it does happen, is it going to be a thermal process, meaning like you just have to give it enough heat for the molecules to collide with each other and the reaction happens? Or is it going to be a photochemical process? Remember the Woodward-Hoffmann rule about the molecular symmetry. The phases have to match where the reaction is taking place. Right, that was the rule. If the phases do not match, the reaction does not take place, or at least it's called like a forbidden reaction. So let's think about that. Right, for any reaction to happen, remember that the interaction is between the HOMO donating electrons into the LUMO of another molecule. The HOMO of one molecule sends electrons to the LUMO of another molecule. When that happens, those two molecules can react with each other. Okay, so that's the whole idea. Okay, so this is kind of the key concept here that I want you to be aware of. So that means if 4 plus 4 cycloaddition, remember 4 plus 4 means there's 1, 2, 3, 4 atoms in one, and then 1, 2, 3, 4 atoms in one. So hence this would be called a 4 plus 4 cycloaddition. If that is a thing, would it happen through thermal process or photochemical process? To figure that out, we need to look at the molecular orbital symmetry of these two molecules. And one is going to react with its HOMO, the other with its LUMO, right? So this right here would be the we would call the ground state, meaning like it's not excited by photochemical or UV light. In the ground state, this is the molecular electron configuration of the pi molecular orbitals for this molecule. Okay, so but let's think about drawing the same thing for the photochemical situation. Okay, so I'm just gonna copy that here. So under photochemical condition, maybe that's not a good place to put it. Oh no. Maybe put it over here, sorry. I guess I'm kind of a newbie at this, making these videos. So under photochemical condition, or I could say under UV light, right? Remember, these electrons can be promoted. Or maybe I should say these things can get promoted, right? And once it does, it will look like, let's see, this electron will now be up there, so it'll be like so. Okay, so this would be now the HOMO, right? Okay, and then the LUMO of another molecule will still be like this. Okay, so hope that makes sense. So the reaction is going to be between the HOMO of the excited molecule and the LUMO of the non-excited molecule if we were to do this under photochemical condition. So what would that look like? The two molecular orbitals will actually be the same, won't they? Because here's the LUMO of one molecule, and then so I just copied and pasted this, and I'm just gonna basically copy and paste the HOMO, the new HOMO that's promoted. Right, so I'm just gonna kind of draw this up, kind of upside down, just so the phases make sense. And lo and behold, the phases actually match, right? Phases match, and so for that reason, this will work, as opposed to if this was a thermal process, then phases will not match, because let's think about that situation. The LUMO will be the same, but the HOMO that will react will be of different orbital, because it will not be like that anymore. Right? And right, the HOMO under thermal condition will be like this. And so this is the orbital that will react. And the orbital will look like this symmetry, right? So one half might react, but the other half, well, I shouldn't say react, the one half might match, but the other half doesn't, so the cycloaddition cannot take place at all. It's not like one side can react and the other side can, because remember, it's a cyclic flow of electrons. It has to happen in one go, or it does not happen at all. So there's mismatch. So for that reason, under thermal condition, this reaction does not take place, but a photochemical condition, this reaction should be able to occur. So that's the conclusion for this problem. Hopefully that was helpful to you.